This is problem number 1 from your Unit 2 study guide, and it's asking us to find a polynomial with integer coefficients that satisfies these conditions. Q has a degree 4, it has zeros at 3i and 4 has an even multiplicity and a leading coefficient of 2. So let's start with the fact that this has an even multiplicity. Well, the only options to have an even multiplicity with a degree of 4 is either the multiplicity is 2 or 4. And since we know 3i is also a 0, we know that the multiplicity here has to be 2. So if we're starting off, we know that q of x equals x minus 4, and that shows up twice. Then we also know that 3i is a 0, so we know x minus 3i is part of our polynomial. And because of the conjugates theorem, we also know that negative 3i is a 0. So that means x plus 3i is part of our polynomial as well. We'll deal with this last part at the end, but for right now, let's go ahead and start multiplying. And it's in your best interest to multiply those two parts that actually have the i's right now, because once you do, it's actually going to look better. So if we FOIL this out, we get x squared plus 3xi minus 3xi and then minus 9i squared. These cancel, and minus 9i squared, well, since I squared is negative 1, negative 9 times negative 1, this is actually a plus 9. So we get x squared plus 9. Then we can go ahead and we can multiply x minus 4, that quantity squared, and we're going to get x squared minus 8x plus 16. And so now it's just a matter of using FOIL and multiplying this out even further. And I'm just going to kind of speed along and show you that what you end up getting here is x to the 4th minus 8x cubed plus 25x squared minus 72x plus 144. So this is so far what we have for q of x. We know that this polynomial has all the zeros that were required of us. Excuse me. So the last part is we need a leading coefficient of 2, and clearly we do not have that. So the only way to get a leading coefficient of 2 without changing all of these zeros is by taking the entire polynomial and multiplying it by 2. You can't just write 2 in the front, that's going to change your zeros. So our final answer for q of x when we distribute the 2 is 2x to the 4th minus 16x cubed plus 50x squared minus 144x plus 288.